When you look up here, in addition to me, you see white walls, purple poster, and this red apple. All of these objects, as you may have guessed by where I'm going with this, in addition to being objects, have a color with them that emerges because of light. Light, visible light, in the electromagnetic spectrum is one region that's particularly important in it for all of us. However, there are also other regions, microwave, infrared, all of those, and those are particularly useful for scientific observations. All objects absorb light that strikes them. However, not all objects absorb light equally. Certain wavelengths are going to be deflected. Those rejected parts of the electromagnetic spectrum form the basis for the visible world around us. Now, for most people in the world, this is an extremely interesting, albeit not very useful, area of knowledge. However, for astronomers, and in particular for planetary scientists, it becomes of the utmost importance. One field where it becomes particularly important, again, is the study of exoplanets. Exoplanets, or extrasolar planets, are planets outside of our own solar system, pretty much anywhere else in the universe. The closest exoplanet to us, Alpha Centauri b, is 4.4 light years away. That means that if this is Alpha Centauri b and light reflects off of it and comes back towards us, it's going to take 4.4 years just to reach our telescopes and observatories on Earth. For reference, the sun, only 8 light minutes away, much smaller. And since we obviously are going to have no light-speed spaceships on the scientific community's 5-year plan or even their 50-year plan, this is an extremely difficult phenomenon to observe. However, despite the vast distances that separate us and all of these other worlds, it will soon be possible to look at them and to observe what they are composed of without ever having to set foot on them. This will be possible because we will be able to look at the reflected electromagnetic spectrum off of them and, using what we know about the interaction of light and matter, determine what their atmospheres and surfaces are composed of. One example that might hit a little bit closer to home is satellites. Satellites are all around Earth, and sometimes they look down, usually for weather-related purposes, towards vegetation or maybe a forest like Joey was talking about, and they look for green because that's a signal that they've found what they're looking for. Now, that first example I gave you about exoplanets may seem way more complicated than the simple one about just finding habitation and general vegetation. However, in reality, it's a familiar phenomenon, light reflecting off of exoplanets back towards us, the same way that we can see that plants are green and that this apple is red. Although we have not been able to make these observations yet of exoplanets, like many things in science, and unlike the exoplanets themselves, we're not far away. Light allows us to see everything else in the universe without doing much all by itself. It allows us to see everything, from the small, such as this red apple, to the large, such as exoplanets hundreds of light years away. Thank you.